Okay, I think I'm gonna call this lecture Trigonometric Integrals Part 2. We're gonna start by finding the integral of tangent to the fifth power times secant to the sixth power. What we're gonna do here, if you have secant and to the an even power, as long as that even power is bigger than 2, you can take the secant to whatever that power is and save a secant square. So this time we're gonna have secant to the 4 power x, and then we're gonna save a secant square. Then everything has to be written in terms of tangent. So, because we save the secant square, we're gonna go ahead and write this as tangent to the fifth power and secant to the second power square, like that, times secant square x dx, like that. And so then this will be tangent to the fifth power, and this secant square, I think is what is secant square equals to I think is 1 plus tangent square. So we have 1 plus tangent square x, like this, and then we square it, and then we have secant square x dx, like that. And so then the idea here is that we have everything in terms of tangent, so we let x equals tangent. Then dx will be equals to secant square dx. So then this will be u to the fifth power times 1 plus u square square du, like that. And multiplying this, so it will be u to the fifth power, and then this will be 1 plus 2 u to the second power plus u to the fourth power du. And then you multiply that out and you get u to the fifth power plus 2u to the seventh power plus u to the ninth power du. And then you integrate that, so you get u to the sixth power divided by 6 plus 2 u to the seventh power to the eighth power divided by 8, and then plus u to the 10th power divided by 10 plus 8. And then you just put tangent for u. So tangent to the sixth power divided by 6 plus tangent to the eighth power divided by 4 plus tangent to the 10th power divided by 10 plus e. So this is what the answer is if you save a secant square. We're gonna go ahead and do this same problem, and basically it says that if the power on tangent is odd, then you save a secant tangent. So that's what we're gonna do in this next page. Same problem, we're gonna get a sort of like a different answer, but they're similar. So we got still tangent to the fifth power, secant to the sixth power, and this time we're gonna save a secant tangent. So we're gonna have tangent to the fourth power, secant to the fifth power, and then secant of x, tangent of x. So we say one secant and one tangent. Then we're gonna take the idea here is to write everything in terms of in terms of secant. So this is tangent to the second power x, like this, square, and then secant to the fifth power x, and then secant x tangent x dx. And then we're going to use the fact that tangent squared is equals to secant squared minus 1. And then that square, and then secant to the 5th power, and then secant tangent. So we're gonna let x equals to secant. Then dx, I'm gonna put this right here. Dx is secant x tangent x dx. Alright, so when you do that, you get u squared minus 1 square u to the 5th power du. That's all it is. And then you multiply, so first of all, this is u to the 4th power minus 2u squared plus 1. You're going to multiply that u to the 5th power du. And then multiplying by u to the 5th power, you get u to the 9th power minus 2u to the 7th power plus u to the 5th power du, like that. And then you integrate. So doing that, you get u to the 10th power divided by 10 minus 2u to the 8th power divided by 8 plus u to the 6th power divided by 6 plus c. And then this time you plug in secant squared for u. So secant to the 10th power x divided by 10 minus secant to the 8th power divided by 4 plus secant to the 6th power divided by 6 plus c. So again, just like the previous lecture that we did on whenever we had sines times cosines, we get a different answer, but they are similar. It's just depending on whether we saved a secant tangent or we save a secant square. Okay, thank you very much.